Hey Algebra 1, Mr. Schafter here. Let's talk about similar figures. This is a big term in geometry. We're just going to skim the surface. Similar figures are figures of the same shape but different size. And there's two very important things you need to know about similar figures. Number one, that the angles of similar figures are equal. And number two, that sides of similar figures are proportional. This is the big one that we're going to use in algebra. Alright, you'll use them both in geometry when you take geometry, but for now we're going to focus on this proportionality of sides. To note something is similar, we use this little tilde, little squiggly line right here. I don't even know if that's called a tilde, but you can fact check me if you'd like. So this means similar. Okay, so the word similar is this little guy right here. So once you're told the triangle ABC is similar to triangle DEF, that means its sides are in proportion. Okay? So we can solve for x. Let's find out what x would be. First of all, be careful, right? This figure, if you were to redraw it to match ABC, triangle ABC, side DE would be over here, DE with the letter F over here. So the length of DF is x, and the length of DE is 4. So now we don't really want to look at this. We want to compare the left one to the right one. And we know that the sides are proportional. What that means is that the left side 5 in this triangle is in ratio to 4, which must be equal to this side 7 over x. And this just means that the proportion between the left side and the left side equals the proportion of the right side to the right side. So this means the sides are proportional. We're going to cross multiply, so we get 5 times x is equal to 5x equals, and then 7 times 4 is equal to 28. And so if we divide both sides by 5, we get that x is equal to 28/5, which we'll just leave it like that because you can't simplify that at all. Alright, so we found out that the side length of that triangle is 28/5 because the figures were similar.